All right, let's take a look at section 10.2, finding arc measures. And where are these arc measures? They're going to be on the outside of the circle. So let's go ahead and begin right here with a lot of vocabulary terms, many of them new. So let's go ahead, make sure you write them down in your notes so that you have a decent idea of what we're actually solving for and how. So the first term that we have right here is that of a central angle. That's an angle whose vertex is at the center of a circle. So I'm going to go ahead right here. I've got a circle, and I'm going to go ahead and draw a dot right at the middle. And I want to draw two rays. Okay, and that right there, this angle that's formed in the middle right here, this would be your central angle. Okay, so the central angle always starts at the center of the circle, and that happens to be your vertex. Okay, now you could use the same circle or draw another one, but I'm going to erase what I just wrote right there and continue on. In our next term we have is minor arc, and inside what I'm going to go ahead is highlight or trace over this arc right here, and that arc happens to be less than 180 degrees. So this will be my minor arc right there. And think about it. 180 is a straight line. So if I have a straight line, that would be your diameter. So if you see a line or you see a diameter, then that means the arc is 180, or it's going to split the circle in half. So if that right there is my minor arc, then I want to go ahead and highlight the bottom portion of this arc right here. And that would be my major arc. Because the major arc is going to be greater than 180 degrees. So then we go back and kind of circle back to what I just mentioned before, is that we have ourselves a semicircle. So if I draw a line or a segment that goes through the center, like that right there in gold, that will be half of the circle, and that will be your semicircle, okay? And that would be 180 degrees. So important to know right here is the measure of the minor arc. What is that? That's going to be the measure of the central angle. Because we're going to talk about a few other arcs later on in the section or in the chapter. But this right here we have, so whatever the arc happens to be, like the one in red or the one in green, that would end up being the measure of the central angle. So if right here in red, let's just say that that happens to be like 120 degrees, then that would be the measure of the central angle. Okay, so the measure of the minor arc. If the minor arc was 120, that means that that angle right there in red would be 120. Okay, so the measure, if the minor arc was 120 degrees, that means that this central angle would be 120. Okay, they're both the same. So the measure of the major arc right here in this instance would be 360 minus 120. Okay, and then that right there would end up being 240, and that's the measure of the major arc of what right there happens to be in green. So, and then remember, all together we're dealing with a circle, and a circle ends up equaling 360 degrees. So that's why, hey, take 360 minus the minor arc. That is the measure of the major arc. Adjacent arcs, hopefully we realize when we talk about adjacent, they are right next to each other. So the adjacent arc right here, two arcs that are side by side. Some other key terms and information. Congruent circles. If circles are congruent, circles have the same radius or radii. Okay, so two circles that have the same radius, that would make them congruent. Okay, simple as that. The radii are the same, then the circles are the same. Next up, for congruent arcs. Arcs that have the same measure and arcs of the same circle or congruent circles will be congruent arcs. Okay, so in order for arcs to be congruent, the radii must be the same, or they must be from the same circle, okay, or congruent circles, okay? And remember, if they're congruent, they have the same radius. Think of it this way. We talked about similar triangles, right? We could have two triangles that have 30, 60, 90, or two triangles that have, all interior angles be 60, equilateral or a regular triangle, but one could be this small, or one could be very large. And they both could be regular. They both have interior angles of 60, but their side lengths will be different, right? Because one is bigger than the other. So let's take a look at some of these core concepts right here. It's more reiterating what we've already mentioned. So the first one, the measure of the minor arc is the measure of its central angle. Okay, so we had talked about that already in the vocabulary terms. And so when you look at the diagram right here, the measure of the arc angle, and we say the M, and then we 2 letters to represent the arc. It's got to at least be 2 points, right, to make up the arc. And so then we put a little cute little arc above the letters to represent arc, and that's 50 degrees. Well, that means the central angle right there ends up equaling 50 as well, the angle that makes up that arc. And so right here, we will say the measure of arc AB, we're talking about the outside. Not to get it confused with the central angle, but they happen to be the same. And then the measure of the entire circle is 360. The measure of the major arc is the difference of 360, and the measure of the related minor arc. And so we talked about that before. Take 360 minus that minor arc, and that will get you the major arc. Now, pay close attention right here. They put right here the measure of arc ADB. So typically, in good practice, I will go in order, whether we go clockwise or counterclockwise. Okay, we'll go in order of the points that happen to be on the outer side of the circle. If I'm talking about the major arc, look, they went A, D, B. And so from there, it's pretty easy to understand that we are talking about those 3 points, and that happens to be the major arc right here. Okay, as opposed to saying A, you won't go A and then decide, hey, I want to go to D and then B, because then you're going like 360, or you're going more than 360 degrees around the circle. So with a little bit of common sense right here, you'll be able to determine which way do I go on the circle. Most of the time, you'll figure it out. There might be times where it's ambiguous, but they might ask for the major or minor arc, and then you'll know which one you're supposed to choose right there. So we have right here the arc addition postulate in postulate 10.1, and pretty much when you take 2 arcs, add them together, you'll be able to get the sum of the 2 arcs, right, or the measures. So right here it says measure of arc ABC. So they're talking about this right here. Let me highlight that in blue. The measure of arc ABC, well, that's going to be equal to the measure of arc AB. I'll go ahead and highlight that. Plus the measure of arc B to C right here. And I'll put that right there in green. So adding those 2 arcs together will get you the entire big arc. Just like angle addition or segment addition postulate that we learned in chapters 1 and 2. Looking at next, Theorem 10.3. Remember, congruent circles. 2 circles are congruent if they have the same radius. Key point, same radius. Otherwise, the circles are different. Okay, the diameters would be different. The outer part, the circumference would be different if the radii happen to be different. All right. Next up, theorem 10.4, we've got right here the congruent central angles theorem. All right, so once again, if we take a look, we've got two angles. Okay, they're central angles and they are of the same circle. One thing that you can determine is that the arc measures are the same. Well, why is that? Check it out. We've got vertical angles, right? And then so what they're also saying right here is that the two minor arcs are congruent if and only if their corresponding central angles are congruent. So because the central angles are congruent, that means that the arcs DE and arc CB will be congruent as well. Okay? We could also say right here arc CD and arc VE are congruent because look, those are vertical angles as well, and those are the arcs opposite of the central angle. All right, so congruent central angles theorem. Let's go to 10.5. Similar circles theorem. Well, all circles are similar because all circles are similar in shape, right? They're all round. The only difference is that if the one circle could have a radii of 1 or radius of 1, the second circle could have a radius of 2. They're still nice round circles with points equidistant from the middle or the center, but one would be larger than the other. So don't forget about that term similar. It is not the same thing as same. All right, so let's go ahead and put this all together right here and take a look at our extra practice. So identify the given arc as major, minor, or a semicircle. So I'm going to go ahead and take a look at the diagram and let's go ahead and draw things out. I'll go ahead and trace things. And right here, I want to go ahead and say that that right there in blue is arc AB. Now, why not go the other way, right? Why not go make it a major arc? Well, the thing right here is this. If I were to go the other direction, I would say arc ADB or arc ACB to make sure that, hey, I know I'm going which direction I'm supposed to go. So make sure you kind of use a little bit of logic to figure out which direction do I go with my major, minor arc, okay? And I'd say about 90% of the time, the book is pretty good about that, making sure you can determine one over the other. And so this right here, could say is the minor arc. And we got to figure out, well, what is the measure of that arc? Okay, well, that's kind of interesting. How am I supposed to do that? Well, let's take a look at some key things here within the figure. All right. I'm going to go ahead. I'm going to draw a line right here from A to C. That line is there, right? So what does that tell me? Okay, well, that right there would be a semicircle if I were to think about half, because that breaks it up into half, right? So that means that this whole entire yellow part arc would be 180. Well, how about this arc right here, A, E, and D? Well, 40 degrees is already accounted for. So then, if I take 180 minus 40, this part right here would be 140, AED. So that we're already starting to break down and take a look at part of our parts of the circle right here. Okay, let's see what else do they give us. If that happens to be 180, take a look. And I see right here at the bottom of the circle, it says that AC is perpendicular to BE. So what that gives me right here is some information to help me get my answer. And the measure of arc AB is going to be 90 degrees. Because it was perpendicular, we get 90 degrees right there. All right, so there we have that. Let's take a look next up at number 2, the measure of arc ABC. Well, with the help of answering number 1 right here, and looking at the semicircle, I actually probably went ahead. Didn't need to know all that. The yellow arc or the gold arc in number 1. But then that means that A, B, C, that arc right there, well, that's going to have to be 180 as well, right? If we go ahead and do this, that's 180. Think about the angles that are now there, and we have ourselves a semicircle, and that's 180 degrees. So let's take a look next on number 3, arc ABD. Okay, well, we have 180. We go a little bit further down with angle D, and that right there is more than 180 degrees. It's 180 plus 40, so 220. And we put it all together. If it's 220 degrees, that is a major arc. Going next up to number 4, arc B to C. Well, we did see from problem number 1, and looking at the highlighted information in purple, with AC as perpendicular to BD, or sorry, AC is perpendicular to BE, BC, well, based off of the central angle, that arc measure will be 90. It's opposite of this 90-degree angle right here. So we have, once again, a minor arc. On number 5, we got arc ABC. Okay, so we got that right there. Or sorry, BAC. So now we're going in reverse. We're actually going counterclockwise. Let me erase some of this right here and show what exactly are we looking at. So we go B counterclockwise to A all the way to C. So we know A to C right there, that's 180. So 180 plus 90 right there. We go ahead, add that up. We got ourselves 270, and that's a major arc. Next up, angle DAB right here. Let me erase what we have right there and take a look. From D, well, now we're going counterclockwise again, A to B. Or sorry, we're going clockwise. DAB, we got 140 plus 90. Okay, so that right there adds up to 230. And we've got major arc. Number 7, we're looking at arc A to D. And I already have that there. We figured that out earlier using the semicircle, 180 minus 40. And so arc AD is 140 as well. And that's going to be a minor arc. It's less than 180. And then lastly, arc C to D. They give you pretty straightforward right there. The central angle is 40, so the arc measure is 40 degrees as well, and that is minor. All right, next up, let's go to number 9. In circle E above, tell whether arc ABC, so let me go ahead and erase some of this. And they're saying, is arc ABC, is that congruent to arc ADC? Okay. And so hopefully we can say why. Don't forget, explaining is equally as important. And remember, from the get-go, we talked about this A to C and the importance of that. So they are congruent, yes. But why? Because A to C, or we can go ahead and talk about first off, segment AC is a diameter. And why is that important? Because that makes ABC is equal to 180, and the measure of arc ADC is also equal to 180. Making them both a semicircle, and the arcs must be congruent. All right. So putting all that together, the measure of ABC is equal to 180. Measure of arc ABC is equal to 180 because AC is a diameter, and that cuts the circle in half. Okay. Let's go ahead now and take a look at number 10. And in number 10, it says in circle K, and not the store, right? Find the measure of arc D to E. So we are trying to find right here arc DE, which happens to look like a minor arc. So how can we put this all together? Okay. There are some key angles that you can hopefully determine and find out. Let's see if you know what first. Take a look at what I'm already highlighting in blue. That tells me what angle CKD happens to be because those are vertical angles, guys. So measure of angle CKD is 55 because it's vertical to angle AKE. So now, hopefully, we see that I'll highlight this piece right here from C to E. That segment, that happens to be a diameter, which will in turn tell this out here, make that arc 180, right? Because it is a semicircle. So if we go ahead and take, 180 minus 55, we can get our answer, and the measure of DE, or the arc DE, is equal to 125. And that's the measure of arc DE. All right, just like that. Last one right here. We take a look at number 11. Find the value of x, okay? And then find the measure of arc AB. So two-parter. If you only get one part right, you may not get the question correct. Okay, so make sure you do it all. So where do I start? I look at the outer part of the circle. I've got information there. Well, remember, what does a circle end up equaling? How many degrees? It's 360. So it's important right here for you to take every single arc, and let's go ahead and write it down. And remember, when it comes to your tests and in your homework, you should have it all there to show your work. All those exterior or the arc measures end up equaling 180. After this, hey, make sure you show how you simplify things. We can combine like terms. I've got 7x. I've got 40 plus 70 plus 75 right here. And that ends up equaling 185. And this is equal to 180. Or, sorry, it's not equal to 180. It's equal to 360. I don't know what I was thinking. Must be tired again. So here we go. The entire circle is 360 because they gave me the entire, added up all of the arcs of the circle. So now, let's go ahead. We'll solve for x. We need to subtract 185 to both sides. And then so 360 minus 185 is 175. Okay, we'll divide both sides by 7, and x is equal to 25. Once again, make sure you guys are showing your work top down, not left to right. Okay, I see the equation up at the top, and I'm seeing how it's getting smaller and getting to my final answer. It's good practice. Your teachers will love you for it. I will like you for it, okay? So let's go. We went ahead and found x. The last thing is find arc AB. And where is A to B? It's right over here. And so the measure of arc AB is equal to 5x. We can go ahead and plug in 5 times 25. And lastly, we have right here 5 times 25 is 125 degrees. And that is the measure of arc AB. Okay? We have now finished section 10.2. If you like what I just did, make sure you guys like, subscribe, and please follow along. All right, take care, and bye-bye.